For industries that demand the highest standards of quality and safety in their operations, Hawke have developed a range of high-performance electrical and mechanical components which are second to none. Hawke has more than 30 years' experience in the design and manufacture of components suitable for a wide range of industrial uses, from commercial and high-tech applications to construction, process and assembly manufacturing. Hawke products result from an extensive knowledge of our markets. The range includes cable glands, junction boxes, control stations, mechanical fire barrier systems, compression couplings and high-integrity connectors for sub-sea applications. Hawke products are ideally suited for use in hazardous areas and have undergone rigorous testing at both the design and manufacturing stage to ensure they are completely dependable in the toughest working environments.
Transit systems were originally developed for the hazardous area market involving oil and petrochemical sectors in the early 1950s. In 1985, Hawke developed their own system, and in doing so were able to draw on their vast, unique experience to produce a system which retained and improved upon the quality of other systems while addressing their problems. Technically, the transit system is a penetration sealing system by which a multitude of cables and/or pipes may pass from one area to another via a wall or division, and in doing so provide a barrier and maintain the integrity of the division against fire, water, and gas at pressure. It can operate within various diverse environments and also provide protection against chemicals, radiation, vibration, sound, and biological ingress. These factors have led to the use of the Hawke transit system in marine and civil applications and, when tested to national and international standards, resulted in approvals by authorities including Lloyd's Register, DNV, ABS, LPC, UL, ULC, Germanischer Lloyd, US Coast Guard, Bureau Veritas, and numerous other authorities, which include ISO 9001 quality systems. A typical transit assembly consists of a frame, modular filler blocks and tolerant blocks, stay plates, compression tool, compression system, and a compression plate. Accessories are also available and include a ratchet spanner, lubricant, end puller, measuring tape, and mastic. There are many types of transit frames available to suit different applications of use and differing installation requirements. Frames are available in two compression system forms, with an integral shrouded bolt compression or with a purpose-designed compression tool. Round transit frames are also available when cables or pipes are required to pass through circular apertures, such as cast pipes, welded tubes, or core-drilled holes. As you will see, the Hawke transit system is simple to install and easily serviced and modified. To assist with the determination of cable sizes and the correct selection of blocks, Hawke have produced an easy-to-use selection gauge, which, when used in conjunction with the Hawke plan, assists in the planning of installation operations. The packing space is indicated on the side of the plan for each of the frame sizes. The tolerant block forms the backbone of the improvements made to the system, introducing tolerance of the variable cable's dimensions into the block design, allowing an approximate 50% reduction in stock to be carried. This is a matter of component design and one considered important enough to patent. Each tolerant block is marked with the cable range for that particular block and carries a colored spot for ease of identification and future inspection. The tolerant blocks are made in two materials, a black elastomer and a green halogen-free material, both specially formulated to meet primary criteria including intumescence, when subject to fire, non-support of combustion, and the material must be flexible and show resilience to a wide range of chemicals and have a good aging profile. The blocks meet these conditions impressively when subject to fire, swelling to fill and seal all gaps left by burning cables, effectively ensuring the integrity of the system. Each tolerant block has been developed with 5 sealing faces to accept a range of cable diameters, as well as being able to seal onto cables which vary in diameter along their length. When the block is compressed, the block material displaces into the purpose-designed grooves. The space taken by each tolerant insert block should be marked on the Hawke plan as required to suit the cables. In this space, allocate the relevant filler blocks. With information on the numbers and size of cables, this initial planning stage can be carried out off-site by the engineering planning personnel. Prior to installation of the blocks, it is necessary to clean and lubricate the frame's internal aperture. Upon assembly, each block should be sparingly lubricated to ease fitting and assist in compression. In practice, it has been found that installation and future modification is aided if larger cables are placed toward the bottom of the frame, graduating in size towards the top of the frame, with the cables spaced in a symmetrical fashion. Dependent on the type of installation, it is recommended that up to 50% free area be allowed in any arrangement for possible future expansion. Whenever practicable, a stay plate should be fitted between each row of blocks. The main function of the stay plate, under normal operating conditions, is to ease assembly and provide an anchor for the tolerant and filler blocks. The stay plate is supplied as standard in stainless steel, although other materials are available. Where pressures in excess of 4 bar can be anticipated, a high-pressure stay plate with a large anchor lug should be used, thus forming a restraint against the frame walls to stop any shifting of the blocks under pressure. Prior to installation of the last row of tolerant and/or filler blocks, the compression plate must be fitted. The compression plate is fitted on top of the module blocks and, when under compression from the end packer, gives a uniformly distributed load effecting a water and gas-tight seal. It should be noted that the compression plate is fitted with a stand-up edge to the back of the frame. This provides a stop for the end packer. Where pressure is of primary importance, we recommend a TA50 packing strip is inserted into the frame in addition to those blocks necessary to complete the packing area. Another major advantage is the introduction of the Hawke compression tool set, which can be used on all frame types to reduce assembly and maintenance time, which is a major labour cost saving. The compression tool is placed centrally between the top of the frame and the compression plate, and using the ratchet tool jacks open the compression tool to partially compress the block assembly and open up the aperture for the end packer assembly. The compression tool also has the advantage of being able to be operated from any angle. With standard transit compression systems, the compression system is activated from inside the frame, and to which access is restricted. Assembly time is therefore longer, and labour costs are increased. After the compression tool has jacked open the assembly to a sufficient distance, the end packer outer blocks can be placed in position with the bolt-threaded position facing the assembler. When the end packer outer blocks are pushed into position, the compression tool can be relieved and removed for use again on the next assembly. The compression system centre block is lubricated prior to being pushed into the space available, and with the bolt-threaded portion facing the assembler. The end packer front plate is then located over the protruding bolts, and the 3 compression nuts evenly tightened in an alternating sequence. Effective sealing compression is obtained when approximately 10 millimeters of the bolt thread protrudes through each nut. Another advantage of the Hawke transit system, especially in large installations, is the availability of the hydraulic compression tool, which is used in place of the standard compression tool, and once again speeds up installation. The hydraulic tool is simply placed in position, the pump valve closed, and the compression tool pumped up to compress the system. The end packer outer blocks are fitted as shown previously, and after which the valve is opened and the tool removed. The center block and front plate are fitted as shown previously. To dismantle the transit assembly for cable removal or addition, the procedure is just the reverse of that previously described for compression. Firstly, the pressure must be relieved by removing the compression nuts and the end packer front plate. For dismantling purposes, Hawke supply a puller tool which is fitted to the center compression bolt and, when fitted against the frame, jacks the center block from the assembly. The compression tool or bolt is then used to open the aperture, which enables the release and removal of the outer end packer blocks. The compression tool or bolt is then relieved and removed, allowing the insert and filler blocks to be removed or rearranged to allow the addition or removal of cables. The Hawke EMP transit system uses all the components of the standard system, the only difference being the coating of the rubber blocks to make them electrically conductive and having a copper tape strip fitted, thus giving the system the ability to screen out stray electrical interference, especially that carried on the cable screen or armor. The cable outer sheath is removed down to the armor braid or screen. The cable is then bound up to its original outside diameter with copper tape and assembled into the frame as with the standard system. Upon complete assembly, the frame will be in direct contact with the cable screens or armor via the tolerant block contact. This system is finding typical uses in computer and military applications where sensitive equipment requires protection afforded by the system. The Hawke round transit system has been designed to effectively seal cables and pipes passing through circular apertures. The seal is formed by tightening the compression bolts, which expand the system radially. This causes pressure to be exerted against the aperture wall and compresses the tolerant blocks around the cables or pipes. The round transit system has an integral extraction facility to enable the assembly to be easily removed from the aperture. The round transit system is also available for applications which have existing cables. Hawke have developed special systems to suit individual customers' requirements and for cables which have non-circular form. To suit cables which have non-circular form, a special block has been developed to fit into the standard tolerant blocks and with internal sealing faces shaped to suit the form of the cable. When completed, the Hawke transit system provides unquestionably the best fire, water, gas and pressure type cable and pipe penetration available, whose integrity is assured by an impressive number of approvals bodies. Insist on the best. Specify Hawke.